All right, welcome to another explain question. This is the 2019 HSC physics paper, question 26. So the scenario we have is a student carried out an experiment to investigate the relationship between the torque produced by a force and the angle at which the force is applied. A 400 Newton force was applied to the same position on the handle of a spanner at different angles as shown. So that's our little picture diagram here. As you can see, that's our little stimulus of showing what's happening in this scenario. A high precision device measured the torque applied to the bolt, and this is the graph we have here. The student concluded that the torque was proportional to angle theta and proposed the model of tau equals k theta, where k is that value there. Now, the first thing I wanted to talk about is they talk about a model, okay? And you can see that's a formula. So a model doesn't just necessarily have to be similar to if a DNA model of the double helix, how would you portray that using like physical entities? But rather in physics, you can also, and in science in general, a model can also be a mathematical formula that is used to do predictions and formulate accurate assumptions. So that will be useful later on when we answer this question. So it says in this question, justify the validity of the student's model, again, their mathematical model, using the information from the graph. So there's a couple of things. Firstly, if you are trying to justify the validity, so, judgment, do you agree? Do you agree with the student's idea? Next bit is validity. Now we know that validity is to find an answer for an aim, but more importantly, if you know you have an answer to a particular aim, that should also show some kind of relationship, right? So some proportional relationship. That's what we're trying to look at. And then the last bit we need to look at is from the graph. So use the graph. If you don't use the graph when you explain this, you won't get the mark. Simple as that. But if you're able to make your judgment, justify it, and then talk about it in terms of graph, then, well, that'll be ideal to get 3 marks. Okay, let's start with this. Now, firstly, the student concluded that the torque was proportional to angle. By the looks of this graph, that is true. If you look at it, torque is increasing, angle is increasing. So they are directly proportional to each other in that part there. So the first bit we can do is our little judgment. So I'm just going to write it down, judgment, student model is valid. Okay, so currently their mathematical model makes sense. It's answering a particular aim. It's showing an actual direct relationship. So what's my justification for it? Okay, from the graph, as you can see, I am trying to link to the graph. From the graph indicates that tau is directly proportional to theta. So that's true. The next claim that they made is k is equal to 1.7. Now, this is where you actually need to have a ruler because we're going to have to draw a line of best fit. The reason being is how they found k is, remember, this is what we graphed. So my rise over run, that's my gradient. My rise here is torque, my run here is theta. So if I readjust that, the gradient would be k. So I'm going to try and see if I can get a value for k. So let's just see if I can actually draw this on. Might struggle here. So obviously it's a little bit hard to use it on a little touch screen, but I'm just going to draw it straight through. It's not perfectly straight, but it'll have to do for now. Now, when it comes to drawing the line of best fit, the line should go through the midpoints of all the dots. My one is probably a little bit under, but that's the idea. Now, the line of best fit should always be slightly out of your first dot and slightly out from your last dot. So that's just to give you extra space in case you might need to do an extrapolation. So predicting data that's not there. When it comes to finding the gradient, this is a little mistake that a lot of kids end up doing, is they kind of choose the points, the data points, as a point to assess for their gradient. That's not how you do it. To find the gradient, it must be data from the line of best fit. So I'm going to use, I'm going to change the color so it's just really obvious for everyone. I'm going to use this dot here, maybe even the cross, and I'm going to use this point here. Okay. Generally, you want to use crosses instead of dots in the HSC exam, just because of scanning reasons. The dots might come up very clear. So that's for your own benefit to plot in crosses. And so I plot this along, plot that along. Okay, so my points here is x is 25, and then my y, roughly, I'd say 41, 42. Estimate it to be 41 then. And then over here we have, that's about 7, and then that is 10. Okay, so put this onto my line of best fit. y2, y1 over x2, x1. So you can be x1, you can be y1, you can be x2, you can be y2. Okay, so y2, 41 minus 10, x2, 25 minus 7. Okay, so if I put that into my calculator, let's see if that gives me a number similar to the k constant. And would you look at that, I got 1.72 Newton meters per a degree. So that's my proof there. What you can do, or what you are allowed to do, is do scribbles on the actual stimulus. They do mark any diagrams or pictorials that you put on the graph, so please show you're working out. Okay, it's that. The gradient value was approximately 1.7, which aligns with the student's prediction of their model. So that's really good. Let's see if there was anything else I wanted to say. Nope. So there we have it. As seen from value graphed of line of best fit. So you need to just make it really clear to the marker that you've done a line of best fit. You've tried to see if the 1.7 Newton meters per degree was actually true when you were graphing this out yourself. Okay, next one. It says, what happens to the accuracy? So accuracy is the closeness of exact value. So how close are you to the real model? Okay, so the real model here. Predictions as angle increases. So we're looking at if theta goes up, what happens to that model of tau k theta beyond 25 degrees. So what we will most likely need to be asked to do is not only do we need to address what happens to this relationship, but give actual values of consideration when it is above 25 degrees. Use every little bit of information they give you and try and give a really quality answer that's based on scientific evidence to form your arguments. So justify your answer with reference to a different model. Now this is where what I said earlier comes back in. Okay, if you recall earlier when I talked about this question, I said a model can be a mathematical model. Okay, so it doesn't have to be some kind of physical thing that you need to construct or anything like that. Model in physics is just equally mathematical or physical there. So my mathematical model, the mathematical model that we know of for torque is this. Okay, so that's our mathematical model. Now, I do know for a fact that that formula here is obviously not the same formula as this, because this doesn't take into account with sine theta there, that's just theta. So first thing again, I'm going to make a judgment on whether or not I think it's an accurate model, okay? Always just, or this is just sort of a stepping stone. If you like to talk about the reasonings first before you make your judgment, that's cool as well. But for those of you who would like to structure it better or not sure how to structure it, this is one way of doing it. So judgment, models prediction, is not accurate, or instead of saying it's not accurate, it becomes less accurate. So the model's prediction becomes less accurate as we go past 25 degrees. Okay, so let's also say an alternative model. So our alternative model is, so alternate model is that RF sine theta instead of tau k theta. Okay, so that is the true formula for torque anyways. Let's just have a quick comparison of the trends. So so we're going to do a couple of calculations. We'll have theta at 25. We'll have, or actually let's start it at 15. Then we'll have it at, what's a good number? 45, theta 90, and then maybe theta at 15, just to give us a little range. So tau that f sine theta and tau k 0. In this case, don't forget that RF is just standing for k. So 1.7 sine 15, that'll be 0.4 or 4, rounded off to 2 sig figs just for this simplicity's sake. 1.2, 1.7, 1.5. And then we'll do it the other way around. So 195, 195, 153, 7, and 15, or 26. Okay, so what you can see here is if I graphed it out, and this is obviously a little bit more detailed than what you probably would need, but this is just for your own understanding. The graph would look like sort of like this, kind of drops down. Okay, and obviously it's a sine, so it's a sine function, so it goes like that. But for this model that we have here, it continues to go linearly up. Okay, so that can't be correct. Okay, so as a comparison to the model, to the proposed model, the students' predictions are inaccurate, predicts a linear increase by increasing theta. Theoretical model, the theoretical model says trend becomes a sine wave. So that's a little bit, I would say, maybe a bit too much with what you would probably need, but try and use a couple of values, maybe 90, 115, to show that the trends wouldn't just go linearly up, it will eventually come back down after a certain angle. Okay, so we have looked at whether it was accurate or not. We said it becomes less accurate as we pass 25 degrees. We also said that we also referenced the actual angles we could use, and we justified our answer with a different model being a different mathematical model. So that's how you do the question.